So good morning, students. So myself, Vijay Shankar from BC Department at Chipdal Engineering College. Today, we are going to discuss about all the examples what we discussed in any analysis of the linear system. So the first one is the impulse response of the continuous time system is given as impulse response of the continuous time sequence system is given as h of t is equal to determine the frequency response and plot the magnitude and phase. This already we discussed, or once again I will explain. Given the time domain function, h of t is equal to e power or 1 by rc e power minus t by rc into mu of t. How to find out the frequency response? Nothing but h of omega. H of omega is equal to integral minus infinite to infinite 1 by rc e power minus t by rc mu of t whole multiply with the e power minus j omega t d. This is a formula for the Fourier transformation to find the given signal in the time domain. 1 by rc is a constant and change the limitations when keep the mu of t is equal to 0 to infinite and apply the integral e power minus t as a common j omega plus 1 by rc whole divided by minus j omega plus 1 by rc. The upper limit is infinite and lower limit is 0. Okay. When we substitute the upper limit e power infinite is 0, when we substitute the lower limit e power 0 is a 1, minus into minus is becomes a plus. Then after simplifying 1 by rc, 1 by 1 j plus 1 by rc. So take the LCM and we'll get the denominator of 1 plus j omega rc. RC get cancelled, h of omega is equal to the frequency response, h of omega is equal to 1 by 1 plus j omega rc. Okay, got the frequency response. And also plot the magnitude and the phase. To plot the magnitude, h of omega is equal to, take this, rationalize this factor, 1 minus j omega rc by, we get a plus b into a minus, a plus b into a minus b is a square minus b square. The minus is becomes a plus when it is a j square plus omega square r square and the c square, or otherwise omega rc whole square. So in this, the magnitude of h of omega is equal to 1 by 1 plus omega rc whole square plus omega rc by 1 plus omega rc whole square under root. This is the magnitude. So simplify the magnitude. The LCM is 1 plus omega rc whole square and in the numerator we'll get the 1 by 1 plus omega rc square. So the total term and the square is get cancelled. You have the under root. So h of omega is equal to, the magnitude of h of omega is equal to 1 by under root of 1 plus omega rc whole square. And angle is h of omega is equal to imaginary coefficient by the real coefficient. What is the imaginary coefficient? Omega rc with this denominator, and the real coefficient is a 1 by with this denominator. So we'll have only the omega rc one, the tan inverse omega rc. Okay. Using these two factors, substitute the omega is equal to 0 and omega is equal to infinite, omega is equal to minus infinite. The magnitude is 1 by under root of 1 plus plus omega RC whole square. And the angle is tan inverse omega RC. Okay. This is the magnitude we have. H of omega is equal to. And angle is tan inverse omega RC. When RC is equal to 1, we considered when RC is equal to 1, the magnitude and the phase 1 by root of 1 plus omega square and minus tan inverse omega. And in this, we can substitute when omega is equal to 0, omega is equal to infinite, and omega is equal to minus infinite. What is the magnitude and the phase? You see the magnitude. A magnitude is when the infinite, 1 minus infinite means 1 by 1 plus infinite. 1 plus infinite means infinite, 1 by infinite is a 0. Okay. And omega is equal to 0 is a 1, and plus infinite is also the value is a 0. Whenever it is a magnitude. Angle h of omega is equal to, when omega is equal to 0, the tan inverse 0 is 0. When omega is equal to plus infinite, you get the minus pi by 2. And minus infinite means minus of minus is becomes plus tan inverse of minus minus tan inverse only. The sine by cos, the sine is odd function. So you get the plus pi by 2. So using this relation, you can draw the magnitude plot. When omega is equal to 0, the h of omega or the magnitude of h of omega is equal to 1, the maximum value. And plus infinite is slowly decreases and goes in the 0. And the symmetric at negative values also you get the 0. Okay, magnitude of h of omega. And phase angle, when omega is equal to 0, and omega is equal to infinite value. So this is an infinite value plus infinite. It becomes of a minus pi by 2. So it varies from the plus pi by 2 to the minus pi by 2. Its magnitude is here, or the magnitude angle is minus pi by plus pi by 2 and minus pi by 2. Got it, my students? The characteristics is like this, the plot of magnitude and the phase. Okay. And go for the another example. For the system shown in the function shown, find the TT and the impulse response, Fourier transform and the impulse response of the system for the f of t e power minus ut, t is greater than 0 and 0 for L square, and y of omega is equal to 1 by the a plus j omega. It is a given function, so you can find out the impulse response. H of omega is equal to, we know the r of omega by the f of omega as the input function. So f of t is given the e power minus ut. What is the f of omega is equal to, we know the e power minus ut mu of t. T is greater than the 0 means the mu of t only. E power minus ut mu of t, the Fourier transformation is 1 by a plus j omega 1. F of omega, and given y of omega is equal to 1 by alpha plus j omega. Alpha plus j omega. H of omega is equal to, as a transfer function, output by the input. Output function is 1 plus alpha by j omega, and input is a plus j omega. F of omega is equal. So a plus j omega by alpha plus j omega is equal to, you can add alpha and subtract the alpha in the above equation, a plus alpha minus alpha plus j omega whole divided by the alpha plus j omega. That is equal to, see the a minus alpha is one term, you can take a minus alpha by alpha plus j omega, and alpha plus j omega by the alpha plus j omega becomes 1. So you get the a minus alpha by a plus j omega. So h of t, here the h of omega is equal to, And after the combining the y of omega to find the impulse response, h of t is equal to, apply the inverse Fourier transformation, h of t is equal to, a minus alpha is a constant. So 1 by alpha plus j omega means e power minus alpha j into or the alpha into t mu of t with the multiplication factor of e minus alpha plus 1. What is a 1? Inverse Fourier transformation delta of t. So we got the impulse response h of t is equal to a minus alpha into e power minus alpha mu of t plus delta of t. Okay, my dear students. Next, another example. The linear system impulse response is e power minus t plus e power minus 3t into mu of t. Find the excitation to produce an output t into e power minus 8t, t into e power minus 2t mu of t. Means given that to produce an output signal t into e power minus t mu of t, find the excitation, nothing but the input function. What is the input function? To get the response is t into e power minus t mu of t. For the impulse response, e power minus 2t plus e power minus 3t into mu of t. So the given there is an impulse response, h of t is equal to e power minus 2t plus e power minus 3t into mu of t. Okay. And output is given r of t. Let us take it is a t into e power minus 2t mu of t. We need the linear system impulse response. Impulse response means h of omega. H of omega. That is r of omega is output. Let us take f of omega is the input function. Okay. F of omega is input, r of omega is output, h of omega is there. We need the f of omega. We need f of omega. So r of omega by h of omega. Okay. So what is an r of omega here? The r of t is given. R of omega is equal to t into e power minus 2t mu of t. E power minus 2t mu of t is 1 by 2 plus j omega as of e power minus 8t mu of t. When it is a t is multiplied, we will get the square term. And h of omega is equal to the two functions we have, e power minus 2t mu of t and e power minus 3t mu of t. For e power minus 2t mu of t is a 1 by 2 plus j omega plus 1 by 3 plus j omega. So r of omega, h of omega we got. Divide these two functions to get the f of omega as an input function. F of omega is equal to r of omega 1 by 2 plus j omega whole square whole divided by h of omega 1 by 2 plus j omega plus 1 by 3 plus j omega. Simplify this function. You'll get the 3 plus j omega in the numerator here plus 2 plus j omega whole divided by 2 plus j omega into 3 plus j omega is totally numerator only, and in the numerator we have 1 by 2 plus j omega whole square. 1 by 2 plus j omega whole square. This becomes of f of omega is equal to 1 by 2 plus j omega whole square multiplied with 2 plus j omega into 3 plus j omega divided by 3 plus j omega, 2 plus j omega, nothing but 5 plus 2j omega. So 1, 2 plus j omega is get cancelled. F of omega is equal to 3 plus j omega pi 2 plus j omega into 5 plus 2j omega. Okay. 5 plus 2j omega. So we have the function, the 3 plus j omega and the 2 plus j omega here. Simplify this or apply the partial fraction expansion method. Find the a and the b values. And then you can apply the inverse Fourier transformation to get the f of t. Okay. And what is the function you can see of the simplification? 3 plus j omega pi, the 2 plus j omega pi into 5 plus 2 j omega. Okay. Take this function 3 plus j omega whole divided by the 2 plus j omega and 5 plus 2 j omega partial fraction a by 2 plus j omega plus b by 5 plus 2 j omega. Okay, this is nothing but f of omega as an input function. F of omega is equal. Okay, and to find the a and b, the 3 plus j omega is equal to a into 5 plus 2 j omega plus b into 2 plus j omega. Compare the constant terms. So 3 is equal to 5a plus 2b. Compare the coefficients. So 1 is equal to 2a plus b. 2a plus b. You can subtract these functions to get the get value. Okay, so one equation, or you can multiply the 2, 4, and here the 2. Multiply the 2 on both sides for the second equation. The 4a. So the coefficients, the j omega coefficient is a 2, and the j omega coefficient is a 2 here, and the j omega coefficient is a 1. So I multiplied the 2 to cancel the b value here. Subtract the term, b get cancelled, a and the 3 minus 1 is equal to 1. So a is equal to 1. Now what is a b? B is equal to, a is equal to 1 means that b is equal to minus 2 minus 1. B is equal to minus 1. So to get the f of omega is equal, not the r of omega, my student, is f of omega as an input function. Already given output function, f of omega is equal to 1 by a is 1, 2 plus j omega plus b is minus 1, 5 plus 2 j omega, but it is in the not the form of e power minus at mu of t. E power minus at mu of t, its Fourier transformation is 1 by a plus j omega 1. So keep that is a j omega as a coefficient is a 1. So bring the 2 as a common, 1 by 2 plus j omega plus minus 1 by, take the 2 as common, j omega plus 5 by 2. 5 by 2. Okay. Now we can apply the inverse Fourier transformation. F of t is equal to e power minus 2t mu of t minus 1 by 2 into e power minus 5 by 2 into t mu of t. Okay, madam. We got the input function f of t is equal to e power minus 2t minus 1 by 2 e power minus 5 by 2 into t mu of. Got it? The same function. It's not the r, f. Okay. H of omega is equal to, already substituting the r of omega only, we got the f of omega is equal to. Got it, my dear students? Next is the differential equation. The differential equation having the A and the B values. According to the differentiation property, d by dt of x of t is j omega into x of omega. Now, any given the function is a linear differential equation, how we can find the impulse response or input responses? Let us take an example. The differential equation of the system is given as d square y of t by dt square plus 5 into dy of t by dt and 6 into y of t is equal to minus dx of t by dt. Okay, my dear students. Determine the frequency response and the impulse response. Frequency response means h of omega. Impulse response is a h of t. The given function is this. So, using the d by dt of x of t, differentiation property, its Fourier transformation is j omega into x of omega. Here the y of t is there, d square. Square term is j omega whole square. And if it is a cube means j omega whole cube and so on. Second derivative, third derivative, whole power n only. If it is a n, t power n is a j power n. For the first function, j omega whole square into y of omega plus 5 into, is the first derivative, j omega into y of omega. And the y of t is a y of omega only. Dx of t by dt is the first derivative minus j omega into x of omega. So in this equation, check the y of omega is a common. We have one term is j omega whole square plus 5j omega plus 6 is equal to minus j omega x of omega. To get the frequency response, h of omega is equal to ratio between of the output by the input, x of omega. What is the x of omega coefficient? Minus j omega. What is the coefficient of y of omega? J omega whole square plus 5j omega plus 6. So it is a square plus x square plus 5x plus 6, x plus 3 into x plus 2. Write this function as a minus j omega pi. Take the factors here, j omega plus 2 and j omega plus 3. See here the j omega square, j omega 2, j omega 3 is a 5 j omega, 2 into 3 is a 6. So using the partial fraction expansion method, find the a and the b. A by the j omega plus 2 plus b by j omega plus 3. The h of omega is equal. Okay. Now, minus j omega is equal to a into j omega plus 3 is equal, not is equal to plus b into j omega plus 2. Okay. Find the constants, compare the constants here. The 0 is equal to a into 3 plus b into 2. Another j omega coefficients minus 1 is equal to 3 into, or the 3, a plus b. 3a plus 2b. Yeah. Okay. Now, to get the value of a, multiply here the 2 and the 2 minus 2. Subtract here. 2 to get cancelled and the 3 minus 2 is a 1. A is equal to 2. You got the a is equal to 2. And a plus b is equal to 1 minus 1. A is equal to 2 means b is equal to minus 3. So a got the 2 and the b is equal to minus 3. To get the h of omega is equal to a as a 2, that is a 2 by j omega plus 2, and b as a minus 3 j omega plus 2. So h of omega we got as a frequency response, impulse response. By the inverse Laplace transform, not the Laplace, Fourier transformation 2 into e power minus 2t mu of t minus 3 into e power minus 3t mu of t as an impulse response h of t is equal. Okay, 2 into e power minus t and minus 3 into e power minus 3, all it is multiplied with the mu of t. Got it, my students? Even if you can given the linear equation also, differential equation or the differential linear equation, you can find the system response and the impulse response. So another example is given. It's a very important example, my students. Listen carefully. The input voltage is given RC circuit. The input voltage to the RC circuit is given by the x of t is equal to t into e power minus t by RC into mu of t. And impulse response of this circuit is given, the h of t is equal to 1 by RC into e power minus t by RC into mu of t. Find the output y of t. Okay. The given function is x of t is equal to t into e power minus t by RC into mu of t, and the h of t is equal to 1 by RC e power minus t by RC into mu of t. We need to find the output. So output is, let us hear the y of t is equal to, with the two inputs, x of t with the convolution of h of t. Okay, and using the one of the property, the convolution time domain, product in the frequency, h of omega into x of omega. What is the x of omega? X of t is given e power t into e power minus t by RC into mu of t, means e power minus at mu of t is 1 by a. A is here the 1 by RC plus j omega. Since it is t is multiplied, it becomes a whole square. 1 by 1 plus RC j omega whole square into h of omega. H of omega is also 1 by RC is already the constant is there, e power minus t. Same will get 1 by RC plus j omega whole, not the whole square, only the term j omega power 1. That is equal to, take the LCM here, RC and RC square, RC whole square, and in the denominator we have 1 plus j omega RC whole square in this first one. And here the 1 by RC is there, RC get cancelled. And another term here, the 1 plus j omega RC is a final term. Here the square term is there, it is a 1 total function. Y of omega is equal. Okay, y of omega is equal to RC square by 1 plus j omega square into 1. Totally the y of omega RC square whole divided by 1 plus j omega RC whole power cube. Okay, now we need the output. Apply the inverse Fourier transformation here also. Apply the inverse Fourier transformation. RC whole cube already we have. RC whole cube already we have. And it is becomes change this function as 1 plus j omega RC whole cube term as is a 1 by j omega. Take the RC whole cube is a common. RC whole cube is a common. In the denominator 1 by. So 1 by RC plus j omega whole cube. Already in the numerator there is RC square is there, not the cube, RC square. So RC square we can write in the numerator. So square and the cube is get cancelled. We get the y of omega is equal to 1 by RC into 1 by RC plus j omega whole cube. So it is in the form of 1 by A plus j omega whole cube. Square means the t is multiplied and the cube is means t square by 2 factorial. To get the apply the inverse Fourier transformation, it becomes of y of t is equal to 1 by RC is a constant. Now here the cube term is there. Can multiply this as a t square by the 2 factorial is a 2 into e power minus 1 by RC into t mu of t. The output function is y of t is equal to 1 by RC t square by 2 e power minus t into RC into mu of t. Okay, my dear students. It's a very, very important. Next, given the h of t is equal to e power minus 5, the magnitude of t is there. For stability, we know the integral minus infinite to infinite, the magnitude of h of t dt is less than the infinite for stable function. Substitute that e power minus 5 magnitude of t and integral minus infinite to infinite e power minus magnitude of t dt. Whether it is less than the infinite, if the system is stable. So the t is a positive and the t is the negative values. For the negative values, minus infinite to the 0. Minus infinite to the 0, the minus into minus becomes a plus e power 5t dt. For the positive values, e power minus 5 into dt. Apply the integral with respect to the t for the exponential value. E power 0, the value is 1 by 5. For the second term, e power 0, 1 by 5. So 1 by 5 is nothing but the 2 by 5. Definitely these are less than the infinite. The system is stable system. The given h of t is equal to e power minus 5t. The system is stable or not, you can find. Use this formula to find the stability. The h of t dt is less than the infinite. The same function e power 4t dt. 4t into mu of t. Mu of t means change the limitations 0 to infinite e power 4t. Upper limit is infinite, that becomes a 0. Lower limit is 0, 1 minus 1 by 4 is a constant value. Definitely this is also the stable system only. Okay. And t into cos t mu of t. T into cos t mu of t. Definitely this is an unstable system only. And e power minus t sin t mu of t is a stable system by using the h of t. T into cos t mu of t. Use the UV rule and e power minus t sin t. Here also use the UV rule and substitute the limitations from 0 to t, 0 to infinite and 0 to infinite. You'll get stable and unstable. When it is a stable, less than the infinite is a stable, equal to infinite, nothing but unstable system. Okay, my dear students. See, from this, see in the next class.